హలో, కనిపిస్తుంది? స్క్రీన్ కనిపిస్తుంది? స్క్రీన్ కనిపిస్తుంది అన్నది.
ఎస్ సార్ కనిపిస్తుంది.
Okay, so today we'll discuss about root locus. So the root locus is nothing but the locus of the roots of a characteristic equation when any one parameter is varied. Okay, so here let us assume that the system is having a transfer function of g of s, which is equal to k by s plus 1. Okay, so here the system is having one pole at s is equal to minus 1. As the value of k varies, this root magnitude varies. Okay, so this is a open loop transfer, open loop system. S is equal to minus 1 is the open loop pole. Then if we take up a closed loop system, the transfer function g of s by r of s is equal to g of s by 1 plus g of s, as your h of s is equal to 1. Okay, so your new transfer function will become k by s plus 1 plus k. Okay, so from this you can have that open loop pole at s is equal to minus 1, but closed loop pole is at s is equal to minus 1 plus k. S is equal to minus of 1 plus k. So that is here s is equal to minus of 1 plus k. Okay, and therefore if k is equal to 0.5, your pole is located at minus 1.5. If k is equal to 1, this pole is located at minus 2. Okay, so that this can be located on the S plane like this. Okay, so here the first pole is at minus 1.5, then this is minus 2, minus 3, minus 4, and this is at minus 11. Okay, and this is minus 16. So these poles are located on the S plane like this. Okay, so the path of this all these poles is called the root locus. The path of all these roots is nothing but the root locus of the system. So now, what is the root locus system? Okay, zero to infinity. Okay, so now how to sketch the root locus?
Hello, hello. Hello, hello. Sajid bhai. Hello, hello.
So can you see my slide? Hello? My screen is visible to you? No. Now? Just a minute. మీకు ఇప్పటిదాకా స్క్రీన్ కనిపించలేదా అండి మీకు?
లేదు సార్, ఇప్పటివరకు ఏమి అనిపించలేదు.
కనీసం ఇన్ఫర్మేషన్ ఏమి నేను మీకు కనిపిస్తుంది అనుకుంటున్నాను. Okay. So once again I will start with this angle and magnitude criteria. Okay, మీకు ఇది కనిపించిందా అండి? ఈ స్క్రీన్ ఈ పాయింట్ కనిపించిందా? Yes.
సార్ ఇక్కడ వరకు వచ్చింది సార్.
ఇక్కడ వచ్చిందా? Okay, so we'll start again. So here let us take that C of S by R of S is equal to K by S plus 1 S plus K. So this is a closed loop pole which is located as 1 minus of 1 plus K. Okay, so the value of pole can be varies with value of K. So if you take K is equal to 0.5 and the pole is located at minus 1.5 and K is equal to 1 minus 2, like that this is the location of all the poles. Now if you join all these points you are going to get that locus. Now this is for only one value of pole. Let us take that there are more number of poles. Okay, so S into S plus 1. So here it is very difficult to find out the value of pole which is located with the variation of your gain K. And therefore it is not possible for each and every value. Therefore we are going for the technique which is called as the root locus technique. Okay, so this root locus technique was developed by W.R. Evans. Okay, and this is normally used in all control systems of engineering. Okay, this is then this method is mainly depends on the angle and magnitude conditions. Okay, so we'll consider a closed loop system which is having G of S into H of S as the forward and feedback transfer functions, and C of S by R of S is the closed loop transfer function which is given by G of S by 1 plus G of S into H of S for any system. And therefore here for this system the characteristic equation is given as 1 plus G of S into H of S is equal to 0. So with the help of this equation we need to get the magnitude and the angle condition. Just I will take up this to right hand side. So your equation will become G of S into H of S is equal to -1 and where this g of s into h of s is a ratio of all polynomials in terms of s, and this g of s in the s of s is a complex quantity, and it can be split into the angle and magnitude conditions. Okay, so as the complex quantity can be represented into angle and magnitude parts, and therefore this angle criteria can be obtained as this angle of g of s and h of s is equal to angle of -1, and this -1 can be represented as plus or minus 180 degrees into 2k plus 1, where k is equal to 1 to 3 and so on. And the magnitude condition is here magnitude of g of s into h of s is equal to the magnitude of 1, so it is equal to 1. So from this, you can easily get the magnitude value of k. Okay, so once you confirm that the root, okay, so satisfies, if the root satisfies the angle condition, now this root can be used in the magnitude condition, and then you can estimate the value of k. Okay, so here these are the angle and magnitude conditions again. The values of s that fulfill both the angle and magnitude conditions are the roots. If the value of s, the value of s which fulfill both the angle and also the magnitude conditions are the roots of the characteristic equation or the roots of the closed loop system, which are called as the closed loop poles. Okay, so a locus of these points in the complex plane satisfying the angle condition alone is the root locus. A root locus or element or point S, okay, which is satisfying the angle condition is the part of root locus. Okay, so to apply the magnitude conditions graphically, we must draw the poles and zeros of g of s and h of s in the S plane. And if let us take that the system given by g of s into h of s is equal to s plus 1 by s into s plus 3 into s plus 4. So these are the poles, the denominator values are poles and the numerator values are called as 0. So this 1 0 at -1, and the remaining all are the poles. So with the help of this, you can find out the magnet angle condition by taking at any point P, okay, and joining this point, test point, to all the poles and zeros. Okay, and then okay, and then theta 3. Hello, వినిపిస్తుందండి? Hello?
Yes, sir,
Is it?
వినిపిస్తుంది సార్.
Okay, okay. Network only disconnect. Okay, so here we need to join all the poles at zeros with a test point P. Then we can have angles theta 1, theta 2,
Excuse me, sir.
then theta 3 and phi 1.
సార్ ఈవినింగ్
Yes.
తీసుకుంటాను లేకపోతే అంటే ఓకే స్ట్రక్ అవుతుంది
ఈవినింగ్ బయట
స్ట్రక్
వినిపించట్లేదా?
అవుతుంది సార్ బ్రేక్ అవుతుంది మధ్యలో మధ్యలో మేబీ సిగ్నల్ ప్రాబ్లం కావచ్చు
అదే నెట్వర్క్ డిస్కనెక్ట్ అవుతుంది. ఒక 15 minutes ఇది ఒక ప్రొసీజర్ చెప్పేసి క్లోజ్ చేస్తాను.
ఓకే సార్ సాయంత్రం ఈవినింగ్ ఫ్రీ ఉన్నారా సార్ మీరు
నేను కొంచెం పని ఉంది, నన్ను బయటకు వెళ్ళాలి. మళ్ళీ వచ్చినాక నైట్ అయినా తీసుకుంటాను నేను.
ఓకే
సేమ్ ఇదే ప్రాబ్లం అవుతుంది ఇక్కడ.
ఓకే సార్
ఓకే, మళ్ళీ ఇప్పుడు ట్రై చేద్దాము. ఒకవేళ మళ్ళీ ఏదైనా ప్రాబ్లమ్ వస్తే క్లోజ్ అండ్ ఈవినింగ్ 8 to 8:30 అలా చెప్తాను.
ఓకే సార్ థ్యాంక్ యూ
జస్ట్ కన్స్ట్రక్షనల్ రూల్ చెప్తాను ఇప్పుడు. సో కనిపిస్తుందా?
ఎస్ సార్ కనబడుతుంది
So here we need to find out the angle theta 1 with respect to this point P, okay, and theta 2, theta 3, and then this phi 1 is the angle with 0. So we need to take the angle of phi 1 with 0 minus this all angles with the poles. So we need to find these total angles and add up all this. So you need to get this value must be plus or minus 180 degrees. So then that point, this test point will be on the root locus. Okay, if you take this point and measure all the angles theta 1, theta 2, theta 3 and phi 1, then you use this formula to measure this angle. If this satisfies plus or minus 180 degrees, then this point is said to be on the root locus, or it is a closed loop pole. Otherwise it will not be a closed loop pole. Okay, so that is the angle condition. Okay, and now we need to measure the lengths. Okay, so that is b1, b2, the length from the test point to the poles. So this will give you the value of the magnitude of the particular transfer function g of s into h of s with a test point p. Okay, so from this test point we need to make up the magnitude a. So a divided by b1, b2, b3. So that is your magnitude. Okay, just as an example, just let us take the given system is k by s into s plus 1 into s plus 2. We need to check that this s is equal to minus 0.25. Okay, is a point on the root locus or not. So we need to check this point. So for that I will take the angle condition. Here the angle will be now the numerator, angle of k, this is going to be 0. Okay, the angle of s, okay, angle of s plus 1 and angle of s plus 2. So here this angle will be now 0. Okay, and this is a 90, and this is a minus 45 minus 2 by 1, tan inverse of 2 by 1. Okay, so for that we need to substitute s is equal to minus 0.25 in all the points. We are interested in finding s is equal to minus 0.25 is the test point which is on the root locus or not. And therefore for that particular value, so we need to substitute s in the magnitude equation. So as this is a k, you cannot substitute here. This is a magnitude of minus 0.25. Okay, so this is angle of minus 0.25. This is angle of minus 0.75 because minus 0.25 plus 1. So this is going to be the plus this is going to be the plus 0.75. Okay, and this is 1.75. So these angles which will contribute, this is a plus angle, so this is a 0. This will contribute to 0 only. and this is as this is a minus angle, this will contribute to minus 180 degrees. So you can see that it is a complex value. So using your calculator also you can find it out. So this is contributing minus 180 degrees. That means this point S is equal to minus 0.25 is the point of root locus. Okay, so here this is a point of root locus. Once you clearly understood that it is a point of root locus, then you can use the magnitude condition. Then you can calculate the value of k. Okay, so this magnitude is equal to 1. Now from the point S is equal to 0.25, and this is a point on the root locus. So you can find out the value of gain k by using this formula. So the magnitude will be k by s into s plus 1 into s plus 2. Just you substitute s is equal to minus 0.25 in this one. Okay, so minus 0.25 minus 0.25 plus 1. So like that, if you substitute this, you are going to get this value as k is equal to 0.3.328. Okay, so this is a way of finding the values of points which are on the root locus, and also to find the value of gain k. ఓకే, ఒకవేళ మీకు ఎగ్జామ్లో ఏదైనా పాయింట్ ఇచ్చి టెస్ట్ పాయింట్ అడిగితే ఏ బిట్కి ఇలా చేయాలి. ఓకే, then just we see the construction rules for the root locus. So these are very very important. మీరు ఈ పాయింట్స్ రాసినా కూడా మీకు అట్లీస్ట్ 60 to 70% మార్క్స్ పడతాయి. ఓకే, so the constructional rules, just always this system will be now represented by some k into g of s by 1 plus k into g of s into h of s. So from that you can get the characteristic equation. Then you can see that magnitude condition and also the angle condition. Okay, so for any point s is equal to s1, which is a point on the root locus. Okay, so you need to satisfy the magnitude and also the angle conditions. Okay, so these are the constructional rules. It is very very important. Just if you uh, take a note of that, you can also take this. Okay, so the number of branches of root locus are equal to n. So where n is the number of open loop holes. Okay, and here m is the number of open loop zeros. The first point is the number of root locus branches are equal to the number of open loop holes. Okay, just you see here the system is having a pole 1. This is a complex pole. Okay, so this is also a complex pole. This is a pole and this is a pole. So 1 2 3 4 5. Okay, so here there are 5 poles are available, and therefore the number of root locus branches for this system must be 5. Okay, so that means here this root locus branch, which is given by the blue line, this is a 1. Okay, and this purple line, this is a root locus branch 2, and this one is a root locus branch 3. This one is a root locus branch 4, and this is 5. So always for any given system, the number of root locus branches are equal to the number of open loop holes. Okay, and then here also just you see this is a pole 1. Okay, so here this is a pole 2, and this is a pole 3. There are 3 poles, therefore there are 3 root locus branches. So this is the root locus branch 1, which is starting from -4 and terminating at -infinity. This is starting from -4 and terminating, this root locus branch is terminating at infinity like this. And here this is the root locus branch 2, which is starting from s is equal to 0, and it is coming here, and then it is moving forward and it is crossing the imaginary axis and reaching to infinity. And the third root locus branch, which is starting from -2, third root locus branch is starting from -2, and then it is breaking here, then it is moving towards the infinity in this fashion. So this is the another root locus branch. So always there are three root locus branches are available as your number of open loop poles n is equal to 3. So for any system, okay, for any system, the number of root locus branches are equal to the number of open loop poles. This is a constructional rule 1. Then the second rule is the root locus is symmetrical about the real axis. Okay, so that means here this is your real axis. So always the root locus is symmetrical about the real axis. Okay, just use observe here the same root locus is representing in the second quadrant, and also that is represented. It is a mirror image in the third quadrant, and that's why we can say that this is a symmetrical about the real axis. And if you observe this also, here the second one, this is like this. So the same value which is mirror image in the third quadrant. Okay, so these are the constructional rules. Just you have to remember. Then third one is the starting and ending points of the root locus. So always the root locus starts at a finite and infinite poles, open loop poles, and it ends at a finite and infinite open loop zeros. Always remember that the root locus starts at pole and ends at 0. Always the root locus starts at pole and terminates at 0. Just you see here, this blue line is starting with the pole and ending at 0. This is starting here, it is breaking away at this point, okay, and then terminating at 0. Then another one, this is a purple line again, this is moving in the right side, then it is coming again terminating at 0. So here just you observe there are n number of just terminating at zeros. Always the open loop pole and ends at open loop 0. Therefore, these two root locus branches terminating at 0 and the remaining root locus branches terminating on infinity. These root locus branches terminating on infinite. So the number of root locus branches terminates at infinity is given by n minus m. This is very, very important. Okay, so the number of root locus branches terminating on infinity is equal to n minus m. Okay, and then for the second problem here, there are n is equal to 3 and m is equal to 0. Okay, and therefore this is a one which is terminating on infinity. The second one is also terminating on infinity. Okay, and then real axis segments on the root locus. So we need to see a real point to exist on the root locus if the sum of finite open loop poles and the sum of the open loop zeros to the right side of that particular point must be an odd number. So here we need to see that this is the root locus branch. Okay, so any system, any pole here, let us assume that which is represented like this here. This is there. This is again pole. So there are three poles which are located on the test plane. So we see that this is a part of root locus or not. So first you take any test point between this 0 and minus 1. You take any test point between 0 and minus 1. Just you take any point. Okay. So this point is root locus or not. This point is on the root locus or not. This can be tested by taking this point and measure to the right side. Okay. Add poles and zeros. add the number of poles and zeros to the right side of this particular test point. If the sum of the poles and zeros are odd number, then this is a part of root locus. Okay, so here from 0 to -1, this is a part of root locus. Then if you take up any test point on the -1 to here, this is a -3 intersection. So you take up any test point between -1 and -3. Just you take up the sum of poles. Sum of poles. This is even number. So this is a not part of root locus. This is a not root locus branch. That is from -1 to -3 is not a part of root locus, and from -1 to infinity, -1 to infinity, minus infinity, this is a part of root locus. Because if you take any test point between -3 to infinity, there are three poles, 1, 2, and 3. Okay, therefore this is a part of root locus. So like this, we need to find out the real axis segments of the root locus. So here, this point, this green line I am taking in the first figure, this is a part of root locus. And then from this point to here, this is a part of root locus. This dotted line, this is a not part of root locus. And for the second figure, from 0 to -2, 0 to -2, this is a part of root locus. Okay, from -2 to -4, this is a not part of a root locus. From -4 to infinity, this is a minus infinity, so this is a part of root locus. Because the test point, if you take any test point to the right side, there are three poles, so that is an odd number. Therefore, this is a part of root locus. Okay, so next one, the number of branches, root locus branches terminating at infinity. This is given by n minus m. Okay, that is the number of open loop poles minus number of open loop zeros. And the meeting point of all these asymptotes is called as a centroid. Okay, so here the centroid is given by sum of the finite poles minus sum of the finite zeros divided by n minus m. So this is the number of open loop poles minus zeros n minus m. Okay, so we need to add the poles and zeros. Then the angle with which asymptotes approaches to infinity. The angles with which asymptotes approaches to infinity are called as the angle of asymptotes. This is given by the formula 2q plus 1 into 180 degrees divided by number of finite poles minus zeros. So this is again n minus m. Denominator value is also n minus m. Okay, so these are some samples of angles of all asymptotes. If only one asymptote is there, that means n minus m is equal to 1. Okay, then angle of asymptote is 180 degrees. If there are two poles which are terminating to infinity, okay, so n minus m is 2, then they will terminate with an angle of plus or minus 90 degrees. If n minus m is equal to 3, then the angles are plus 60, minus 60, and 180 degrees. Okay, so if the number of asymptotes n minus m is equal to 4, this will be equal to plus 45, minus 45, plus 135, and minus 135. Okay, so this with these angles, these asymptotes, the asymptotes will terminate towards the infinite. Okay, then now here there is a breakaway or break-in points. So there are poles here. This is a part of a root locus, and therefore this root locus branch is starting from this pole, and this root locus branch starting from 0, and then meeting at a particular point, and then it is breakaway. So this is called as a breakaway point. So these dotted lines here, these dotted lines are called as the asymptotes. Okay, these dotted lines, these are called as the asymptotes. Okay, and the meeting point of this asymptotes is called as a centroid. This is a centroid here. Okay, the meeting point of this asymptotes is called the centroid. And now, after getting the centroid and angle of asymptotes, now we need to see that the 6-point breakaway are breaking points. If there are zeros are available, so 0, then root locus branches will be coming here, okay, like this. So this is a break-in point. Root locus branches uh, starts like this, and they will end at the 0. End at 0. So this point is called as a break-in point. Break-in point. If this is a poles, they are leaving from this real axis and meeting towards the infinity. Okay, so this point is called as a breakaway point. Okay, so this breakaway point can be obtained as by using the characteristic equation. Okay, so here we need to take the value of k. So k into g of s into h of s is equal to 1. So k is equal to 1 by g of s into h of s. Given k, always remember we need to write the given transfer function in terms of k, and then you differentiate this k with respect to s and make it to 0. Or you need to write the equation in k, then you make that as a dk by ds is equal to 0. హలో అజిత్ కనిపిస్తుందా?
నో సార్, కనబడట్లేదు.
స్క్రీన్ రావట్లే?
నో సార్, షేర్ కావట్లేదు.
హలో సాజిద్,
సార్
కనిపిస్తుందా?
నో సార్, కనబడట్లేదు సార్. Okay, guys, log out now. Sir will update time in group.